Hello students, today we are continuing with the nephron. This is still 11.3 and if you remember from previous videos where we looked at the kidney, we said that there is a functional unit within the kidney called the nephron, and we said that there's millions of nephrons within the kidney itself. So today we're going to be looking at the components of the nephron, and your skill is to be able to annotate a diagram of the nephron. So right here in this structure, you see the diagram of the nephron, and you see that all the different parts of the nephron are labeled. So your job is to be able to explain what these different parts do. If you click on the image, you see where one structure begins and the other one ends, and it shows you that via the color coding. So let's start with the efferent arterial here. So this is where blood coming from your body that needs to be filtered comes into the nephron. So first it enters into the Bowman's capsule, which is this capsule right here. Now within the Bowman's capsule you see a network of capillaries called the glomerulus. So the Bowman's capsule here encloses the glomerulus, and here in the Bowman's capsule is where filtration is going to start. So if I scroll down here, you see that there's three main processes or three main stages that happen within the nephron. We have ultrafiltration, selective reabsorption, and osmoregulation. So here in the Bowman's capsule within the glomerulus is where we have ultrafiltration. All right, so most of the blood gets filtered here, but it still needs to go through this tubule that's folded, which is called the proximal convoluted tubule. And notice that there's two tubules. We have the proximal and we have the distal. So selective reabsorption happens here, and we're going to look at what exactly happens in this selective reabsorption. But remember that a lot of materials got filtered here within the Bowman's capsule, and some of that material needs to come back. So some of that selective reabsorption happens within the proximal and then the distal convoluted tubule. So let's write that down. So after the proximal convoluted tubule, this leads into the loop of Henle. When we look at the loop of Henle in more detail, we are going to see that depending on the organism and the habitat of the organism, whether they live in desert-like conditions or in conditions where there's a lot of water, the size of the loop of Henle changes, and that tells you a little bit of the evolutionary history of the organism. So within the loop of Henle is where we have osmoregulation happening. And again, we're going to look into these processes a little bit in more detail in the next videos. So after the loop of Henle, the filtrate, which is the filtered blood, goes into the distal convoluted tubule for more selective reabsorption, and then it kind of ends in the collecting duct. And notice that the collecting duct is shared by different nephrons coming in different parts of the kidney. The collecting duct, again, we're going to be looking at how we're going to be looking at it in more detail a little bit later, but we're also going to see how more osmoregulation and water retention happens within the collecting duct. Okay. What else do we need to know here? So I told you that this is the efferent arterial. So this is where the unfiltered blood comes in. But also notice that once the blood gets filtered here, it leaves through the efferent, I like to think of E as exit, the efferent arterial. And then that efferent arterial is going to branch out into a network of arteries called the Vasorecta. Network of arteries called the Vasorecta. And notice here that this Vasorecta is going to join with other capillaries, and then it's going to join into other venules here in blue. Okay, so once all this is happening within the kidney, the osmoregulation here in the loop of Henle, the selective reabsorption here in the proximal convoluted tubule, it's happening because the blood that's coming in through the vasorecta, right, it's getting absorbed here into these different parts of the kidney, and then when it comes out here and back into your body, it's going to be clean blood, right? It's going to be blood that's been filtered out of all of the toxins that might carry, right, because of metabolic wastes, most of these nitrogenous wastes, and it's going to be filtered and cleaned, but also making sure that not a lot of water gets lost, and then all of that blood is going to come out here through this efferent venule here in the kidney. So then that means that the collecting duct here is just going to carry waste, right? And this is the waste that we think of as urine. So those are the different parts of the nephron, and here you see the different processes that happen within the nephron, right? So if we were to extend the nephron like this, we would see the Bowman's capsule here with the glomerulus where ultrafiltration happens. Then we would see the proximal and distal convoluted tubule where selective reabsorption happens. And then we see the loop of Henle where osmoregulation happens. And this is where a salt gradient is established. And then we see in the collecting duct that osmoregulation happens. And water is going to be kind of held in place here within the collecting duct. And then that's going to allow water from the collecting duct to be drawn out into the loop of Henle when the loop of Henle establishes a salt gradient. So some of the water here is going to go in this direction. Right? So remember, this is important so that the organism doesn't dehydrate. So if you need to retain more water because you live in a dry desert environment, then it makes sense that the loop of Henle is going to be really long, right? Because you're going to need to absorb more water from the collecting duct. If you live in areas where perhaps you don't need to, or where you don't need that much water because you have plenty of water around you, then the loop of Henle is going to be smaller. And we're going to look at that in videos coming up. Okay, so that's it for today. You have really good definitions here of each of the components of the loop of Henle. I'm sorry, of the nephron, not the loop of Henle. So you can use these for your annotations. All right, that's it for now.